Welcome to the DIY Honda Garage channel. The diagnostic trouble code P2648 indicates a low voltage condition within the rocker arm oil control solenoid circuit for the Honda Civic models from 2006 to 2011. The rocker arm oil control solenoid plays a crucial role in the variable valve timing and lift electronic control VTEC system of the engine. It ensures that the rocker arms are positioned correctly to optimize engine performance and efficiency based on driving conditions. When the circuit registers a low voltage, it could lead to improper engine functioning, reduced power, and potential engine damage. Identifying and resolving this issue is vital to restoring optimal performance. Therefore, diagnostic procedures must be followed step by step to pinpoint the exact cause and rectify it. The rocker arm oil control solenoid is a critical component situated near the cylinder head, responsible for regulating oil flow to the VTEC system. It operates via signals from the engine control module, ECM, or powertrain control module, PCM, allowing the engine's valve timing to adjust under various conditions. By doing so, it enables the engine to deliver both high-performance output at higher RPMs while ensuring fuel efficiency at lower RPMs. If the circuit indicates a low voltage, it may result from various issues such as wiring problems, a faulty solenoid, or ECM malfunctions. The successful operation of this solenoid is paramount for maintaining the efficiency of the vehicle's engine and overall drivetrain. Therefore, understanding its role helps in appreciating the need for immediate troubleshooting upon discovering the P2648 code. Several potential causes can lead to the emergence of the P2648 code. First, loose terminal connections can disrupt the circuit, preventing the solenoid from receiving the necessary voltage for operation. Second, a faulty rocker arm oil control solenoid itself may not function correctly, leading to low voltage reading. Third, wiring issues such as frayed wires or shorts can impede the power flow to the solenoid, further contributing to the low voltage condition. Each of these causes can result in poor engine performance and require meticulous examination during the troubleshooting process. Identifying the specific cause is essential to effectively resolve the P2648 code and restore the vehicle to its optimal operating condition. The emergence of DTC P2648 can manifest several symptoms, significantly affecting the vehicle's performance. Notably, drivers may experience reduced engine performance, particularly during high-demand conditions, due to the compromised operation of the VTEC system. Additionally, increased fuel consumption may be noted as the engine struggles to maintain efficiency, which can lead to higher operational costs. Drivers may also observe irregular engine behavior, including unusual noises or vibrations, particularly when the VTEC system is supposed to engage. These symptoms can impact the driving experience and indicate a need for immediate diagnostic troubleshooting to prevent further damage to the engine and associated components. The first step in troubleshooting the P2648 code involves turning the ignition switch to the on-to position. This action powers the vehicle's electrical systems without starting the engine. It is crucial to record all freeze data, which consists of the conditions recorded when the diagnostic trouble code was triggered, including vehicle speed, engine RPM, and others. This data provides invaluable insight into the circumstances surrounding the error, aiding the technician in diagnosing the issue accurately. Additionally, reviewing the general troubleshooting information, whether from the vehicle's repair manual or technical service bulletins, supplements the diagnostic process by ensuring that all relevant factors are considered. Performing these initial procedures establishes a solid foundation for the troubleshooting steps that follow. After initiating the diagnostic process, the next step is to clear the diagnostic trouble code, DTC, using the Honda Diagnostic System, HDS. The HDS is a specialized tool designed for Honda vehicles, enabling technicians to reset codes and performing advanced diagnostics. Clearing the DTC removes the fault indication from the vehicle's system, allowing for real-time testing. Once cleared, obtaining an accurate snapshot of the vehicle's functioning becomes possible without the interference of previous fault codes. This step prepares the technician to conduct the VTech test outlined in the next procedures, ensuring that any transient or intermittent issues can be identified effectively. The third step in the troubleshooting process requires performing the VTech test using the Honda Diagnostic System. This test evaluates the operability of the VTech system components, specifically assessing whether the rocker arm oil control solenoid is functioning correctly. After running the test, technicians must assess the results. If the test is successful, indicated by a yes, it implies that the system is functioning normally at that moment. However, if the result is no, it denotes a failure that necessitates further diagnosis. This step is critical for identifying intermittent failures that might not present during visual inspections, guiding the technician to the next troubleshooting steps accurately. Once the VTech test results have been evaluated, the next step requires turning the ignition switch to the lock 0 position. This action ensures that all electrical systems are powered down, providing a safe working environment before proceeding with inspection or repairs. Preparing for the solenoid inspection involves ensuring that necessary tools are ready and correctly positioned. Safety is paramount during this step, as working on electrical components presents potential hazards. Ensuring the ignition is off reduces the risk of accidental shorts or injuries, while technicians proceed to inspect the rocker arm oil control solenoid connection. The fifth step entails disconnecting the rocker arm oil control solenoid by removing the 2P connector. This action allows for the next vital procedure, measuring the resistance across the solenoid's terminals. Technicians should be diligent in ensuring that the disconnection is performed gently to avoid damaging the connector or solenoid. Resistance measurement is a critical diagnostic step, providing insight into whether the solenoid is functioning within the expected range of 14 to 30 ohms at room temperature. Following wiring diagrams is crucial during this process, as they provide necessary visual aids to navigate connections accurately. Proper measurement can confirm or rule out the solenoid's operational integrity, shaping further troubleshooting efforts. At this stage, the technician will measure the resistance between the rocker arm oil control solenoid's 2P connector terminals, specifically looking for a reading between 14 and 30 ohms at room temperature. This specification determines whether the solenoid is functioning appropriately. A reading within this range indicates that the solenoid is operational and suggests that the issue may lie elsewhere, such as the wiring or connections. If the ohmic measurement confirms normal operation, the technician will proceed to the next series of tests focused on the engine control module, ECM, or powertrain control module, PCM. Conversely, if the resistance falls outside of the specified range, it indicates a fault within the solenoid itself, prompting the technician to consider solenoid replacement as the next course of action. The seventh step involves jumping the SCS line using the Honda Diagnostic System, which is essential for bypassing the vehicle's safety protocols temporarily. This action allows technicians to conduct specific tests without interference from existing codes or systems that may inhibit diagnostic procedures. Before proceeding, it is critical that the HDS is correctly configured and connected to the vehicle to ensure accurate data readings and functional tests. This setup is vital, as it prepares the technician for the next crucial step, checking the continuity between the ECM, PCM, and the rocker arm oil control solenoid circuit. Following this procedure allows for more precise troubleshooting, particularly in diagnosing wiring issues that could be contributing to the P2648 code. As part of the 8th troubleshooting step, the technician must disconnect the ECM-PCM connector B, typically comprising 44 pins. This step is crucial as it prepares the technician for continuity testing, which aims to examine whether there are any disruptions in the wiring from the ECM-PCM to the rocker arm oil control solenoid. Care should be taken to avoid damaging the connector or pins during disconnection, as it could lead to further complications down the road. Removing this connector also allows for a clear pathway to test connectivity and ensure the integrity of the wiring between the components. Accurate continuity checks will specify if the wiring harness has any shorts or breaks, inhibiting proper signaling and functioning of the solenoid. After disconnecting the ECM-PCM connector, the technician is tasked with checking for continuity between terminal B34 of the ECM-PCM and the body ground. This step is vital, as continuity ensures that the electrical pathway is intact, allowing the rocker arm oil control solenoid to receive the necessary signals for operation. If continuity exists, repairs should be made for any shorts detected in the wiring between the ECM-PCM and the rocker arm oil control solenoid, as this indicates a fault that must be rectified for proper functionality. On the contrary, if continuity is not present, that suggests additional wiring issues that may be further diagnosed, leading the technician to potential additional troubleshooting steps that address the specific cause of the malfunction. If the technician determines the resistance reading from the rocker arm oil control solenoid falls outside of the specified range, the appropriate action is to replace the rocker arm oil control valve. This replacement effectively addresses the malfunctioning component responsible for the P2648 code and aims to restore normal electrical function within the circuit. Following the replacement, it is essential to confirm the new solenoid's operational integrity by rechecking resistance levels and ensuring they align within the acceptable range. After confirming functionality, reassembling connections securely is paramount, ensuring no loose ends or potential faults occur post-repair. This thorough approach finalizes the repair process, setting the stage for proper testing before the vehicle returns to regular operation. The 11th step involves carefully reconnecting all connectors that were previously disturbed during the diagnostic and repair process. This includes the rocker arm oil control solenoids connection, the ECM-PCM connections, and any other connectors involved during the troubleshooting steps. Restoring these electrical connections is critical, as it ensures that the entire system can operate effectively once again. Attention to detail is needed to confirm that all connectors are seated correctly to prevent any future intermittent issues. This step forms a vital part of the repair protocol, emphasizing the importance of thoroughness. A well-executed reconnection process lays the foundation for future reliability in system operation. In the final step of the diagnostic procedure for DTC P2648, the ignition switch must be turned back to the on second position. This action allows the technician to reevaluate the system for any active diagnostic trouble codes following the repair. Checking for new DTCs ensures that earlier issues have been resolved and that the solenoid and associated circuits are functioning correctly. Following this, performing a road test or driving the vehicle under various conditions allows the technician to assess the overall performance of the engine under its original operating conditions. verifying that the performance now aligns with manufacturer specifications, indicates successful troubleshooting and repair of the issue associated with the P2648 code. After concluding the step-by-step troubleshooting procedures, it's essential to conduct a final repair verification to ensure that the repairs have effectively resolved the P2648 issue. This step involves checking the entire system's functioning, confirming that all connectors are secure, and ensuring no new diagnostic trouble codes have emerged. The absence of DTCs indicates that the system operates correctly and within specified parameters. Additionally, validating performance improvements through test drives helps establish that the vehicle operates smoothly, with the VTEC system functioning as intended. This step encapsulates the essence of ensuring that the repair has been successful and that the customer is receiving a fully operational vehicle once more. To prevent further occurrences of DTC P2648, it's crucial to integrate preventive maintenance practices associated with the rocker arm oil control solenoid and the VTEC system. Regularly inspecting electrical connectors and wiring harnesses can help catch potential issues before they escalate into more significant problems. Additionally, adhering to recommended oil change intervals ensures the engine operates with optimal lubrication, reducing wear and contributing to the effective performance of the solenoid. Routine testing of the VTEC system functionality also ensures all components are working harmoniously, preemptively identifying faults before they develop into persistent DTC errors. These proactive measures form a part of an extensive vehicle maintenance regimen that aids performance longevity and reliability. In conclusion, the P2648 diagnostic trouble code points to an issue with the rocker arm oil control solenoid circuit and requires systematic troubleshooting for effective resolution. Understanding the roles of affected components and carefully following a structured diagnostic process lead to accurate identification and rectification of issues. Once repairs are successfully executed, performing thorough testing ensures operational integrity. Implementing preventive measures fosters reliability in the vehicle's performance, helping to avoid future occurrences of similar errors. By effectively addressing the P2648 code, vehicle owners can maintain optimal engine performance and longevity, ultimately ensuring a better driving experience. Please like and subscribe to the channel. See you next time.